Hello everyone, and welcome to this short video showing you how to document an interdisciplinary workflow using the MaRDMO plugin. To use MaRDMO, you need the Research Data Management Organizer, or short RDMO, which is usually provided to you by your research institute or some research project, or let's say the National Research Infrastructure. And then in your RDMO instance, you can simply click on create a new project. You can give this project some title related to your workflow, and then you can choose down here basically the catalog you want to use, and in this case we want to use now the MaRDMO catalog to do a workflow documentation. And then you simply click on create new project and you can start documenting. However, I will not do this here because I already created a project which I called the Logical Data Analysis for Egyptian Objects, which will be also the name for our documented workflow. And when we click on it, we can get some further information about this project, which is not so interesting for us now. But then we can click also on answer questions, and then we simply start going through the catalog provided by the MaRDMO plugin. In the first step now, MaRDMO wants to know from us what we would like to do in the next steps, and in this case we would like to do a workflow documentation. The other option for us would be to do a workflow search, which will be explained in an additional video. To do now a workflow documentation, you have to state which person is doing this workflow documentation. So in this case it's me, Marco Weidelbach, who can be identified by some ORCID ID, and this will be just used to allow you later on to edit your own workflows through MaRDMO, and also to give you some credit for the work you put in to get this workflow documentation done. Then some further questions regarding some technicalities. So MaRDMO would like to know from you if you would like to document the workflow only locally for you and download it as a markdown file, or if you would like to publish the documented workflow on the MaRD portal, something like a Wikidata for mathematics, and share it there with other researchers such that they can find your workflow, reuse it or reproduce it. And the other thing that MaRDMO wants to know from you is if you would like to get a preview of your workflow documentation, so just to check if everything's rendered correctly, or if you have some mistakes in there, or if you would like to publish it now. And we always suggest to researchers to of course publish it on the MaRD portal, but of course also to get a preview before doing so. That would be it for all the technicality stuff, and thereby we get to the first section of the sections which are more about the workflow. And in this first section we would like to get a general description of the workflow, so where we at first want to know about the workflow problem, the objective and the procedure. The first question would be if the workflow has already been published, and in this case it's not published. Then we would like to know which kind of workflow we are going to document. In this case we are going to document a computational workflow, but you could also document a workflow where you do something based on experimentally measured data. Then you would have to describe or state the workflow problem in a very short sentence. So in this case it would be something like common destruction patterns in Egyptian objects from the Cachette Kanak. And then you would have to provide some research objective, which in this case would be something like do destruction patterns in these Egyptian objects from the Cachette Kanak follow specific rules. And for the people knowing Wikidata, this research objective would be used together with the name of the project you provided before to give the item on Wikidata a label and a description. And then in the final question on this page here, we would have to provide a short description of the workflow procedure. We will describe the workflow in much more detail later on in the questionnaire, but this is more just a shorthand, human-readable version of the workflow procedure. And there you can see that it starts with extracting relevant objects from the Cachette Kanak database, then define significant object properties, encode them in binary strings, extract the logical rules, and check the rules for scientific and statistical relevance. Thereby we can continue to the next section or next set of questions where we basically connect the workflow to existing research disciplines and mathematical areas. So our workflow basically belongs to the area of Boolean algebra, which we can directly assign from Wikidata, and it of course on the non-mathematical side belongs to Egyptology. Then in the last question on this page, MaRDMO wants to know more about the data streams in this workflow, and in this workflow we basically have two data streams. One is that we have basically objects which are binary encoded in some spreadsheet file going from Egyptology to mathematics, and then the mathematicians are doing some mathematical calculations, and at the end logical rules about the objects are going as IPython notebook from mathematics back to Egyptology for the researchers there to simply think about the statistical and scientific relevance of these rules. And thereby we are already finished the general description, and we will now continue with the second section, which is focused on the underlying mathematical model, which is in connection with the so-called MathModDB ontology, an ontology for mathematical models developed in the MaRDI project. In this case here, it's not connected to the real MathModDB knowledge graph, since this is not yet publicly available. Instead, I connected here to my local MaRDI portal. And at first now, MaRDMO would like to know which mathematical model we are using in this workflow, and if this is already in MathModDB. So in my local version here there is not much in there, it's just the diffusion model actually, so I have to click on no, it's not in MathModDB yet, and thereby I can now define this new mathematical model. So I've just called it here the object comparison model, which is a model comparing objects using a Boolean ring over the object properties. It's stated, or it's invented in some publication, and it has certain properties. So for once the model is deterministic, and on the other hand the model is dimensionless. Then we also have to assign, according to the MathModDB ontology, some research field to the mathematical model. Again, this research field is not yet in MathModDB, and the same for the research problem, which is also not yet in MathModDB. In the next question, it is about so often, or in some cases, you do not only have one mathematical model in your workflow, but more than one. In this case, we don't want to document another mathematical model, and we also don't want to relate the new mathematical model to anything else, so therefore we click here on no. Then MaRDMO would like to know which quantities and quantity kinds are related to this new mathematical model. So for example, a quantity would be something like a more specific quantity, like, I don't know, angular speed, or angular velocity, and the quantity kind would be then just velocity. In this case, the quantities we need here are not yet in MathModDB, so we would like to add them further. Okay, so that would be the first section about the mathematical model, and now we basically have to go more into the details for all the stuff that we not yet already selected from MathModDB. And as you maybe remember from before, we haven't selected a research field, which is of course in this case basically just Egyptology, with all the information we already have seen before from Wikidata. So that would be just basically the minimal input MaRDMO expects at this point. But of course, if we would like to do, we can go one step further, and we can simply say, okay, there is another research field, archaeology, which is also on Wikidata, and this is actually a generalization of Egyptology. This is not mandatory to do this, but of course it's quite beneficial for the knowledge graph to get more information, more connections, and thereby it's also more easy to relate different things to each other. Then once the research field is finished, we can continue with the research problem, which is in this case something like identify the structuring rules in ancient Egyptian objects. So as a description, we have common destruction patterns in objects from the Kashif to Kanak, which suggest that specific rules govern these occurrences, and this problem is related to Egyptology, and it's modeled by the model that we defined before. As quantities, we have several things which are not so much physical quantities, but more other stuff. So for example, we have object properties, which are dimensionless properties, things like does an Egyptian statue still has his head, or is it without a head, and this would be encoded in 0 or 1s. Then we have as another quantity the Boolean ring, a power set, number of object properties, the ideal, and the Gröbner basis. So that would be all the related quantities. Some of them are already on Wikidata, some of them are not on Wikidata. Thereby we would then continue with the related quantity kinds. So as I said before, the quantity signs are more, so to say, overarching quantities, and in this case, for example, one quantity kind we have would be Boolean, again something that's on Wikidata, so a data type that represents true or false values, and this is basically just a generalization of the object properties we defined before, and the same basically for integer, which is a number that can be written without a fraction or decimal, again on Wikidata, which is a generalization for the number of object properties. And that would be it for the quantity kinds, and thereby we could continue with the mathematical formulation. And again, the mathematical formulation we're using here is not in MaRDMO, so therefore we define it here. It's the object comparison formulation, which is basically a Boolean ring over the m object properties, and again it's deterministic and dimensionless. And here would be the formula, so the Boolean ring is a power set. Is a power set of all these m object properties, and then we define the individual terms in this formula. So this would be the Boolean ring, this would be the power set, this would be the object properties, the number of object properties, and so on. And of course, this formulation here is contained in the object comparison model. You may see here that there is another mathematical formulation defined up here, but just for clarity, we will now at first continue to the next section, which is about the related mathematical task. And what we want to do in this workflow is, of course, to extract logical rules. So the task for this model is to extract logical rules, and this task basically applies our object comparison model, and it's related to our problem identifying the structure rules in ancient Egyptian objects. And it's actually a computational task, so at this point it can only be a computational task, but in the future there may also be some other tasks that would be selectable by the user. And then of course this mathematical task here, or this computational task, uses its own formulation, which would be the logical rule extraction formulation. And thereby we go now one section back and can have a look at this logical rule extraction formulation, which again has some properties, and is basically something like this: that the Gröbner basis is a function of the ideal of the Boolean ring. Again, the individual symbols are explained down here using the quantities, and that would be it for this formulation of the mathematical task. And from this formulation we can basically retrieve, or we can basically take back that the formulation contains as input our Boolean ring, which is then from which we then determine the ideal, and then the Gröbner basis is the output of the computational task here. And then finally, as a last step in the documentation of the mathematical model, we simply take again the publication we already used before for the object comparison model, and say this publication invents this object comparison model, and thereby we finished the documentation of the mathematical model using the MaRDMO ontology. And thereby we continue now to the process information section, and in the first step here we would need to define the software that we used in this workflow, and this would be, for example, Python, which we selected here already from the local MaRDMO portal, and then we'd have to define the version of Python that we used here, the dependencies of this, and if the software is version published and documented, and we did this not only for Python but also for Julia. We also use for the Jupyter Notebook and for another software which is called Oscar, a computer algebra system, which is basically programmed in Julia and has some SW-math identifier and is has some certain dependencies here, and again it's version published and so on, blah blah blah. Okay, so once all software is documented, we can continue with the hardware, and in this case it's just my Lenovo laptop with some processor and some compilers available, and so not much to say there. And of course, when you would have a experimental measurement workflow, would also have to say something about the devices used in your workflow. But at this point, in this workflow, that's not relevant. Then we would come to the section of the input data. So let's say, put it a little more like this, like relevant input data that should appear on the MaRDMO portal as individuals, so to say. And that would be in this case the Boolean encoding of the ancient Egyptian statues, which you can retrieve through some GitHub repositories. Actually a small data set, and it's basically just a dense matrix and some spreadsheet, and it's text and it's not proprietary, and we should publish it, and it should be archived, of course, the obligatory 10 years. Same basically for the output data, so the extracted logical rules, again, they're present in some GitHub repository, small data set, stored in an IPython notebook, again text and not proprietary, and yeah, we should again publish it and archive it for some time. Then MaRDMO wants to know more about the methods used in this workflow, and what we're using here is basically the rules and pattern algorithm to determine the Grübner basis from the object properties, so to say. As main subject, we assign here the Boolean ring, and it's basically this formula that the Grübner basis function of the ideal of the Boolean ring, and we can basically get the RAP algorithm again through some GitHub repository, and the relevant parameter of this algorithm is the monomial order, and it's implemented or written or realized through the Julia programming language. And then finally we should say more about the process steps of the workflow, and overall we have 5 process steps which we have already seen before in short, so to say. The first process step would be something like extract relevant objects from the Cachette de Karnak, and here it's just like this, that the Cachette de Karnak has a lot of statues in it, but scientists decided basically to just take 333 of them to basically get a subset of these ancient Egyptian objects, so there we don't have to provide any deeper methods or parameters to do so. The same basically for defining potentially significant object properties, so this is again just something that needs to be done without any methods or underlying software, whatever. Then the objects are basically encoded into binary strings using the object properties, and thereby from the subset of ancient Egyptian objects and object properties we end up with the Boolean encoding of ancient Egyptian statues, which is the input data we defined before, and which can be retrieved through via GitHub, so to say. Then another process step would be, or the next process step would be to extract the logical rules by using the rules and pattern algorithm. Therefore we basically take these Boolean encoding and we extract the rules using the rules and pattern algorithm with the monomial order as a parameter, and this is done in Jupyter notebooks, and it's associated to the Boolean algebra as a mathematical area. And finally then these logical rules that we extracted need to be interpreted, and again this is done without any mathematical methods or parameters and without an environment, just by looking and thinking about them. And thereby we are finished with the process information section, and thus need to give some further comments about the reproducibility. So in this case, the workflow is reproducible mathematically, its runtime is reproducible, the results are reproducible, and it's reproducible on either hardware. And we can also use the model not just for ancient Egyptian objects, but also of course for other objects, and also for things like actors in a play or whatever. And thereby we can use this workflow basically rather versatile in many different disciplines. And thereby we are basically finished with the workflow documentation, and now we can get the standard output from MaRDMO by simply clicking on View Answers, and there you could simply see what you have answered to the individual questions. So it's not that nice actually. Therefore, what we are doing here is now that we go to MaRDMO export and query, and there we get a more nicer view on this workflow documentation. So you can see here first the problem statement section, and then there is some model section here, and the section on the process information with all the process steps, the applied method, the software used, the hardware used, the input and output data, and also the reproducibility section. And then finally we could say, okay, now we are fine with this workflow documentation. Then we simply go again into the questionnaire and to this documentation section, and then we say no, now we want to publish it finally on the MaRDMO portal. Click again on MaRDMO export and query, wait a few seconds, and then we can simply see, oh, the export was successful, and then we can simply follow the link to the wiki page of this newly created workflow documentation, and where basically all information is now in a human readable form as a wiki page. And then also the most important information also stored in the MaRDMO knowledge graph. So there you have this logical data analysis for Egyptian objects item now with the research objective as description, and this is an instance of a research workflow. It's associated with Egyptology and Boolean algebra, and it uses the model we defined, the algorithm we defined, and the software we selected, and the input and output data we defined, and it's authored or created by me. And thereby I hope I could show you or make clear to you how to document the workflow using the MaRDMO plugin, and feel free to try it out yourself.